Hi everyone and welcome back to NTE. In today's video what we're going to look at is permutations that have restrictions, right? So in the first example I'm going to use the restriction on letters, right? And then we will look at more examples in future videos, right? So with this one we want to find out in how many ways can the letters of the word architecture, right, be arranged if the H and the A, right, must be together. Right. So the crux of the matter when we're looking at letters, right, is that your examiner is trying to test if you know what to do when you have similar items, right? Because at the end of the day, rearranging basically letters is the same as arranging people in a row, right? This A and H, right, could be two people that you are actually required to sit next to each other, right? So it's the same concept, right? It's just that there's the added step, right, of realizing that some of these letters are similar to each other, and thus you then have to apply the concepts that we learned about what do you do when there's similar items in your permutation, right? So the first thing you would do is that you would count how many letters do you have in your word, right? And in this word architecture, right, I found that there is 12 letters in total, right? So that means that you have actually 12 positions to fill, right? So that's one option, right? Now you have to basically calculate what are the total number of arrangements that you can make, right? So from there, we are just going to have to do sort of like a bookkeeping system, right? So we go across this word and we just record how many letters do we have. So now in order to solve this, right, I'm going to show you basically two different methods, right? Right, so how does method 1 work? Right, so method 1 says that you need to consider this group that they wanted you to actually put together, right? You have to consider it as one of the items, right? So instead of having 12 different positions, right, you now condense this down to only 11 positions, right? So it's like you combine these two positions, right, as just one big position to fill, right? Then you still have 10 remaining positions. So that shrinks you down from 12 positions or 12 items or 12 letters, whichever way you want to think about it, right? It condenses you down to just 11 letters, right? Or you can think of this as objects, right? So then from there, you can just go straight to calculating the number of arrangements. So that's going to be, well, these 11 objects, right, if you had to pretend that they were distinct, right, then you know that you could arrange them in 11 factorial ways, right? But then inside of this little box, right, so this first position there, right, you know that the A and the H can basically swap position, right? So you then have to consider the rearrangement of those two, right? And you consider that by just multiplying this by 2 factorial, right? But then now you have to come back to reality and realize that in these remaining 10 positions, right, you have certain letters which are similar to each other, right? You have this R, okay, the C, the T, and the E, which are all similar to each other, right? So you're going to have to divide out all of the similarity, right? So you're going to have 2 factorial, right, times 2 factorial times 2 factorial times 2 factorial, right? So this over here basically gives you your total number of arrangements. Okay, so then that gives you 4 million, right, 989,600 arrangements, right? So that's a lot of arrangements. Now let's look at method number 2, right? So method number 2 is my method, right? It's the method that I use and it's the method that I'm comfortable with, right? So in this method, what you do is you consider the positions, right, that this little group that you must make, the positions that that group can take, right, and then you also think about arrangements, right. So basically the framework is position times arrangement, right. So here is one of the positions, right, you can see it over there, right, but is this the only position where you can put this A and H? Definitely not, right. I can put this A and H anywhere along this line, right. So the first thing I think of is how many, so the number of positions, right, of the group AH, right. So how many positions can this group take, right? So I can see that I can also group them together over here, right? Or I can group them together over here, there, right, and so on. Okay, so when you do that, right, you'll see that the number of positions that this group AH, right, can take is a total of 11 positions, right? But now what about the rearrangement, right, of this group? We've already spoken about this, right? We saw that this A and H can swap positions, right? So then, which means that they can rearrange themselves, right, in 2 factorial ways, right? Now, I then need to consider the rearrangement or the arrangements, okay, of these remaining letters, right, in these remaining 10 positions, right? And in order to do that, you can just consider one of the cases, right? So consider case 1, right, where these two, where the A and the H, right, are basically in position 1 and in position 2, right? So you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then you have your A and your H over here. Now these remaining letters, right, I can see that there's 10 of them, right. Now if I pretend that they are all distinct, then I know I can rearrange them in 10 factorial ways, but then reality is they are not all distinct. So then I need to come back to this list and divide out the similarities, which is going to be the 2 factorial times the 2 factorial times the 2 factorial times the 2 factorial. Right, now to put it all together, right, so therefore the number of arrangements, this is just going to be an application of the fundamental counting principle, right, because I went through a series of 3 choices, right. So the first choice that I made was the position of this group, right, so that's 11. Second choice that I made was the rearrangement of the letters in the group, right? So whether I put the A first or I put the H first, right, in that group, right? So I had 2 factorial rearrangements there. That's my second choice, right, multiplied by this third choice that I made. Okay, so the rearrangement of the remaining 10 letters. Okay, so then we're going to plug that into the calculator as well. Right, and that gives you exactly the same answer, right? 4,989,600 arrangements, right? Then you now have the choice, right, to decide which method is more comfortable to you, right? Are you more comfortable, right, just thinking of the group, right, that they wanted you to create, thinking of that as just a single new item, right? So collapsing it down, Or are you comfortable about thinking of all the different choices that you have to go through, right? So first of all, thinking about position, then arrangement within that position, and then arrangement of the remaining items, right? So that's the difference between method 1 and method 2, but at the end of the day, it will all give you the same answer. Okay,